Hello everyone, now I am giving a video lecture on properties of fluids. We'll see the contents. In the contents, first one is the introduction to fluid mechanics and second one is types of fluids, properties of fluids. We'll come to the introduction of fluids. Fluid mechanics is a branch of engineering science which deals with the study of fluids. We can divide this fluid mechanics into three types, that is fluid statistics and then fluid dynamics and then fluid kinematics. What is mean by fluid statistics means the study of fluids which is at rest is called fluid statistics. What is meant by fluid kinematics? That means the study of fluids when are in motion but without considering the pressure forces is called fluid kinematics. Then we come to the fluid dynamics. The study of fluids which are in motion by considering the pressure force is called fluid dynamics. Next we will come to the definition of fluid. What is meant by fluid? Fluid is a substance which is capable of flowing. From the definition of fluid, we can say that in universe any matter can exist in three phases, that is solid, liquid, gas. So solid holds the shape of the container or it has some fixed volume. Then come to the liquid. When you pour a liquid in a container, it takes the shape of the container and it has free surface and fixed volume. And when in the case of gas, it also occupies the shape of the container and volume of a container. In fluid mechanics, fluids are categorized as two types. One is the liquid and then gases. So you can see in this image. So in the solid, all molecules are together. In the gas, it has are separated very large distance. In the liquids are separated some distance. Next, come to the properties of fluids. I have given here a list, that is density, specific weight, specific gravity, viscosity, surface tension. Now I will explain one by one. First, take the density. What do you mean by density? It is also termed as specific mass or mass density. So what do you mean by density means it is defined as the ratio of mass. It is a mass of substance per unit volume, that is mass per unit volume. It is designated by rho, that is mass by volume, that is meter cube by L cube. You can see here the density of water is 1000 meter cube kg. You can see in this figure, if you take a water in a beaker, if you throw a cork and then rock into that water, so what will happen? The rock will sink. Why? Means the rock has dense than the cork. If you see in this another example, so these are the liquids. First, if you pour the honey and then golden syrup, washing up liquid, milk and then purple water, vegetable oil. So by observing this image, you can say that honey has more dense than these oils. Next, come to the second property, that is specific weight. Specific weight is defined as the ratio of weight by volume. So it is denoted by W or in some case gamma. So it is also defined the product of density into gravity. The SI unit for specific weight is Newton per meter cube. The water has specific value, has given 9814 Newton per meter cube. Next property, specific volume. You can say that it is a reciprocal of density, that is, or you can define is the ratio of volume of a fluid to its mass. The SI unit for specific volume is meter cube per kg. Next, come to the another property, specific gravity. It is denoted by letter capital S. It is defined as a ratio of weight density to a fluid to the weight density of standard fluid. It is denoted by S. It is a dimensionless quantity. That is, here you can take, that is from the definition, capital S is equal to weight density of a liquid. That means if you want to measure the specific gravity of any liquid, you need to take here. And then weight density of standards. In case of liquid, we will take the standard fluid as water. In case of gases, we will take the standard fluid as air. So you can say the formula density is equal to specific gravity into 1000 kg per meter cube. We know that the specific gravity of mercury is 13.6. Next, come to specific gravity is also known as relative density. Next, come to the another property, important property, viscosity. Viscosity is nothing but the resistance of a liquid to flow of molecules slides over and other. You can say that viscosity depends on the strength of IMF. IMF means intermolecular forces. So IMF, stronger IFM means higher viscosity. If lower means the fluid has lower viscosity. So viscosity decreases with an increase in temperature. Suppose if you heat the syrup, then the viscosity decreases. That is, you can say that if you increase the temperature, the viscosity of fluid decreases. So you can next is Newton law of viscosity. That means the fluids obey the Newton law of viscosity then the fluids comes under the Newtonian fluids. So in this image you can see the formula Newton law of viscosity is given by tau is equal to mu into du by dy. So you can see here the tau is nothing but shear stress, and then mu is nothing but viscosity of fluid. Du by dy is shear rate or rate of strain gradient. Here mu is nothing but dynamic viscosity or coefficient of viscosity. You can see in the example for Newton law of fluids is air, water, oil, gasoline, alcohol, kerosene, benzene, glycerin. Next. So we'll define the viscosity as two types, that is dynamic or absolute and kinematic viscosity. What is meant by dynamic viscosity? Means it is a tangential force per unit area required to move one horizontal plane with respect to the other at unit velocity when maintained at a distance separated by the fluid. It is denoted by mu. The SI unit for dynamic or absolute viscosity is Newton second per Newton second meter. The other unit is, you can say, it is a poise. What is meant by kinematic viscosity? So you can see in this image the viscosity of different liquids. In this image it has low viscosity, this fluid has low viscosity. So if you consider this liquid, this has higher viscosity. You can see this video. So if you take a bitumen and then peanut butter, ketchup, maple syrup, olive oil, so if you throw a ball, you can see here bitumen has a higher viscosity than the coffee cream. So you can see in this video. Next, kinematic viscosity means you can define it as a ratio of dynamic viscosity to the density. The SI unit for kinematic viscosity is meter square per second. The another unit for is Stoke. Next, what are the applications of viscosity? So with transparent and storing facility for fluid, that is pipes and tanks, and then bitumen used for road construction, we can say that is a higher viscosity, and then drilling for oil and gas requires sensitive viscosity, and there are so many numerous applications of the viscosity property. Next, come to the surface tension. What is meant by surface tension? The surface tension is the ability of the surface of a liquid to act like a thin or flexible film or membrane. You can say that the surface tension is the amount of work required to extend a liquid surface. So in this image you can see, so the droplet takes on a spherical shape since a sphere has the smallest surface area in a given volume, that is surface area. So you can see here the magnitude of repulsive force per unit length is called surface tension or coefficient of surface tension. The surface tension is denoted by sigma letter. You can say the force per unit length. The SI unit for surface tension is Newton per meter square. You can see in this image the water sliders can walk on water because of the surface tension of the water. So the surface tension means, that is, suppose if we take a water, we can take a molecule A, molecule B, and then molecule C. So water in molecule has many binding partners. You know that water at surface has exposed charges to leftover at the surface here. So potential of water is higher, and then deforming droplet to increase the surface area take place. Next, what is the applications of surface tension? So there are numerous applications of surface tension. First one is the evaluation focus to liquids, and also ability of surfactant to decrease surface tension, and then wettability, permeability between solid and then liquid. So characterization of liquid, that is ink and then substance, and then emulsification, that means dressing, manipulation, cosmetics. So quality of control of degradical or management of chain cycle. So you can see the relation between surface tension and the difference of pressure between the inside and outside of a liquid drop is given by, that is, what is the difference of pressure